This is the video for the day 2 set of notes for solving equations with variables on both sides. This is actually the second video that I've made for this section. The first day when we did this, we did the little exploration activity dealing with area and perimeter, and then we also just solved some regular equations that may have had distribution in variables on both sides. So today we're going to focus on two special types of equations, and those are ones that have an infinite number of solutions and those that have no solution. So notice that I have two equations here on your notes next to two statements. So when we started our notes today, I showed you an example of each, and then we did some mixed review practice. So I'm just going to go through those examples with you again. If you look at the first equation, so I'm going to take this one and I'm going to rework it down here. So we have negative 2 times 4y plus 1 equals negative 8y minus 2. Okay, so just like with any equation, because normally when you look at these, you're not going to know that it's a special type of equation until you start solving it. So we're going to start our steps just like we have with every other equation, and we're going to try to clean up our problem on the left and right. So notice on the left here we have parentheses, so that's telling me I need to distribute. Now when I do that, I'm going to get negative 8y minus 2 equals negative 8y minus 2. Now some of you at this point will notice, hey, this is the same on both sides of the equal sign. Well, if it's the same on both sides, then that is called an identity. And that means that no matter what value I use for y, these are always going to remain balanced, because you're doing the exact same thing on both sides of this equal sign. Now, some of you, you'll be rocking and rolling and solving your equation, and you'll never even notice that you have the same thing. So you'll continue to solve. So you will add 8y to both sides to move your variables to one side. And then at that point, you're going to notice, hey, positive and negative 8y cancel on the left, and I bring down my negative 2, and positive and negative 8y cancel on the right, and I bring down my negative 2. Then at that point, once again, you notice you still have an identity. Negative 2 is equal to negative 2. That's true. So you can't just stop. You can't just leave it like this and act like you don't know what to do. You need to tell me that y has an infinite number of solutions. You actually have to interpret the answer. So if you have an identity, then you know that y is equal to an infinite number of solutions. Okay? So that's what an identity looks like. Now let's go ahead and look at the second type of equation. So I'm going to take that and rewrite it. So I have 3 times 5x plus 2 equals 15x. Once again, you're not going to know you're looking at anything special, so you're just going to start solving as normal. So you're going to distribute your 3 because you see those parentheses, and you're going to get 15x plus 6 equals 15x. Now at this point, some of you may start thinking, okay, there's no way this is going to work, because if I have a number times 15 and I add 6 to it, it's never going to be equal to that same number times 15 unless I added 6 to it. But some of you won't notice, and you'll keep going. So you will probably subtract 15x from the left and right, thinking that you need to get all your variables to one side. Those are going to cancel, and you bring down 6, and then you notice that 15x minus 15x cancels, and you get 0. Now, 6 does not equal 0. That is not a true statement. And at that point, hopefully you realize that there is no solution for this equation. There is no value of x that will make this true. Okay? So those are the two special types of equations that we looked at. We looked at identities, which have an infinite number of solutions, and we looked at when there is no solution. After we did these, we worked some examples, and then we worked a word problem. So I want to go over that word problem with you just to make sure you understood. Okay, so the first thing you should do whenever you see a word problem is read it. So I'm going to take a second. I'm going to read this to you even though I know you can read. So it says, a boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat travels 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, so let's think about this problem for a minute. We know that the distance is the same, right? I mean, if I go downstream to a certain place and then I turn around from that place and go back to where I started, the distance has to be equal. However, the time that it takes is not, because you're traveling at a different rate, okay? So this problem is going to use the distance formula. So we went over that in class, but just to make sure, you should know that distance is equal to rate times time. Okay, so we have a lot of this information and we're going to use it to find how far the boat traveled. Okay, so we know the distance is equal. So what I'm going to do is I'm going to set an expression up for rate times time for my trip downstream, and then my rate times time for my distance upstream. Okay, so that's what I'm doing now. So I know right here that it took 4 hours to go upstream. So that means my rate, which is what I don't know, is x, and my time is 4 hours. So I know that 4 hours times the rate that I traveled will be equal to the distance that I traveled upstream. So I know that that has to be equal to my return trip. So this one's a little bit trickier. So they tell you that you went 3 miles per hour faster downstream. So remember, your x in this problem is actually your speed, right? That's your rate. So I know that on this side of the equation that x is being increased by 3 because I went 3 miles an hour faster whenever I went downstream. Okay? All right. Then it also tells me that my time, so look at your equation up here. You're supposed to do rate times time. So I know that the time it took me to travel this was 2.8 hours. So I'm going to write 2.8. Now some people, they don't like it written like this. It throws them off. So I'm going to rewrite this in a more pleasing to the eye format. So I know that I have 4x equal to 2.8 times x plus 3. Okay? All right, so now I should be able to solve this. So the first thing that I'm going to do is I am going to clean up this right side of the equation by distributing. I know that I need to distribute because I see those parentheses. So I have 2.8x, and then 3 times 2.8 is 8.4. So plus 8.4. All right, now remember, this is part of our solving equations with variables on both sides. So I distributed, and now I'm going to move all my variables to one side and all my constants are going to be on the other. So I need to move this 2.8 to the other side. So the opposite of positive 2.8 is negative 2.8. So I'm going to subtract that from both sides. The positive and negative 2.8x will cancel. I bring down my 8.4. And on this left side, if I had 4x minus 2.8x, I get 1.2x. Okay? Now I'm left with a one-step equation. So the opposite of multiplying by 1.2 would be to divide both sides by 1.2. 1.2x divided by 1.2 will leave me with 1x. And then I have 8.4 divided by 1.2, which is equal to 7. Now I want to go back to my problem and just make sure that I'm answering the question that's being asked. So the question says, how far does the boat travel upstream? Well, let's go back to our problem here. We said that x was the speed or the rate that we were traveling. So 7 means that I was going 7 miles per hour. So I need to use that to find my distance. So I can plug it in right here, or I can plug it in right here. It shouldn't matter because remember the distance traveled was equal. So if I do 4 times 7, I find out that I should have traveled 28 miles. So the actual answer to the problem would be that the boat traveled 28 miles upstream. And all I did is take this 7, because that's what x equals, and I plugged it in right there for x. Now, if you wanted to check to make sure that you did it correctly, you could plug in that same value right there for x. Well, 7 plus 3 is 10, and 10 times 2.8 is still 28 miles. Okay? All right, so if you have any questions about this, please come in for tutoring. Don't forget, you will have an assessment over this coming up soon, and I hope you guys have a fantastic evening.